Hello everyone, my name is Amir Golalipour. I'm with Federal Highway Administration. I'm the program manager for resilience infrastructure and pavement surface characteristics. I'm part of the Office of Research Development Technology. That's basically the research arm of Federal Highway. And today I'm going to talk more about some of our recent activities in terms of resilience and also, more about the resilient pavement and infrastructure. Okay. So before we get too deep about the discussion about the resilience, we need to define the terminology that we have a baseline of discussion. Federal Highway has a definition for resilience. It's the ability to anticipate, to prepare for, and adapt to changing conditions, withstand, respond, and recover rapidly from disruptions. And this is part of the FHWA Order 5520. And why this is important for us is because a lot of communities around the nation, they are already experiencing extreme events. And that's why it's important for Federal Highway to try to address resilience. Some of the environmental impacts, it's important to recognize them, especially for our pavement and infrastructure. This study was done at Turner Fairbank Highway Research Center by the LTPP program, Long-Term Pavement Performance Program, and showed that about 36% of total damage for flexible pavement just comes from the environmental factors. And for rigid pavement was about 24%. So it shows to us that how much of our basically damages coming just from the environmental factors, not related to load or any other thing. So it's important for us to have accurate climatic data when we are trying to design our pavement or infrastructure. However, right now, the way that, for example, we are designing our pavement, we basically use the historical data and stationarity. We don't look at the future climate projection. So it's important for us to consider. So what happens if we assume the stationarity for flexible pavement design, for example, for the climate? Based on the climate change models, we are going to have a higher average temperature. So it's going to have more rutting and shoving for our pavement. We are going to have more aging for binder. We are going to have more moisture and increased precipitation. That's going to impact the modulus of our soil, is going to impact the damage on the pavement, the moisture damage, or a lot of other things related to the foundation. The same for the rigid pavements. If we not consider the climate projection and with the change in the climate, for example, if we are looking at the average temperature, we are going to have a higher average temperature. So that means that we are going to have more basically temperature related warping for our concrete. If we have higher extreme temperature, we are going to have more blowups. So it's very important to consider the climate projections. So some of our activities, that is applications related to the pavement and infrastructure, is to look at adaptation strategies. The first step in adaptation strategy is monitoring the trends. Basically, just looking at how your pavement indicators or infrastructure indicators have changed based on the climate change. For example, for asphalt pavement, the indicators are rotting, low temperature cracking, block cracking, how they are changing based on the basically climate change, and we monitoring those. The same for concrete pavement or other infrastructure. Then when the trend differs, we need to start evaluating that pavement or infrastructure, that part of your asset. We need to evaluate vulnerability for that. We at Federal Highway, we have basically develop a tool is called Vulnerability Assessment and Adaptation Framework. It's a free tool that you can use, and you can put your local asset data, and basically it gives you the priority of your asset in terms of vulnerability. So if your asset is very vulnerable or it's very at risk, that asset comes at the top of your list, so you can address the issues with that. And the last step is that try to plan and design your infrastructure to meet future conditions. For this step also, we have developed a tool. We call it Adaptation Decision Making Assessment Process, or ADAP process. You can see basically the framework of that. Again, this is a free tool that is available on our website, and you can tailor that to each country, to your region, and it's a risk-based approach. Some of our case studies that I wanted to share with you regarding resilience. We have done some studies. It's called Transportation Engineering Approaches to Climate Resiliency, or TICR studies, we call them. This is a list of few of them, and I'm going to talk about a couple of these studies. The first one that I'm going to talk about is the one that we did in Dallas, Texas. The proposed project was a new construction, and we wanted to study the temperature and precipitation impact on the pavement. However, we were trying to use the future climate projections, and we wanted to use basic pavement design software to see what's going to happen. So for future climate change, we were using these RCP models. These RCP models are representative concentration pathway model, we call it. Basically, they are trying to show that based on different amount of greenhouse gases, how much changes you are going to have in your climate. The RCP 8.5 is the extreme one, the higher extreme one, and the RCP 4.5 is more conservative, basically. So as you can see, if we are using RCP 8.5 in our modeling, we are going to have up to 9-10 degrees increase in the temperature. So we need to consider that in our design of infrastructure. Also, for the moisture, we use the Thorndike Moisture Index, or TMI. And as you can see, if again we look at the RCP 8.5, there is a little bit more extreme scenario. We are going to have a significant drop in the annual TMI. So that means that we are going to have less moisture. So we have that's going to cause more aridity, and it's going to impact our infrastructure performance. This slide shows the impact to flexible pavements based on the RCP 8.5. Again, in this study, we use different models, but for the sake of having a shorter presentation, I'm just looking at 8.5 that is a little bit more extreme. And you can see that we are going to have a lot of rotting for our pavements, no matter if it's a new construction or rehabilitation. So how we can take care of it, we need to use a stiffer binder grade, and that will take care of that. How about for our rigid pavements? It shows that the impacts could be on the shrinkage of that or curling stresses. The solution for this specific case was to use higher steel content in basic continuous reinforced concrete pavements. So some of the lesson learned is that we need to consider the climate change or the future climate projection in our design. And we can see that based on increasing temperature and aridity, it's going to impact our material. We are going to have a drier soil, we are going to have a softer binder, and it's going to impact our performance. One thing that was very important is that there are a lot of these resilient strategies that they already existed. There was no major cost increase, it's just we needed to consider the climate change and future climate projection to be able to address those. Another site that I'm going to show you quickly was in the Maine. It's basically the northeast part of United States. And we wanted to look at the temperature and precipitation impact on pavement performance. And it was a rural highway. It was not a major highway. And we wanted to use mechanistic empirical pavement performance model to see that what's happening. Based on this study, we saw that the rutting and crackings increased, and we had to do something in terms of the thickness of pavement or using some modified binder. Otherwise, we couldn't take care of the damages. Another important part was that in some of those northern states in the United States, because we are having changing basically in temperature, now the freeze and thaw cycle has changed. So it's going to impact the truckload restriction for our pavement because of the warming trends. So we need to have some consideration about the seasonal policies. Here I summarize some of our resilience resources. They are all free. So if you go to Federal Highway, you can just search Federal Highway resilience. You can see a lot of these studies. We have reports, we have executive summaries, and those tools that I talked about, they are here, they are all free, so you can use them. And lastly, I'm going to talk about some of our ongoing efforts. We did a project on flooded pavements. So we wanted to look at what's going to happen to my pavement when it's flooded if you have a standing water on top of it. We wanted to look at the what's the impact of the emergency and heavy equipment on the pavement after the flooding. So this project was focused on that, and based on that, we developed a decision support tool. Right now, the report has been finished. We are just working with our publication process with Federal Highway. Hopefully, we should have it in the next month or two. If you are interested in this report, you can reach out directly to me, and I will be, and as soon as the report is published, I will be able to share that with you. Another project that is very important is the work that we are doing with the National Oceanic and Atmospheric Administration, or NOAA. It's a collaboration project between Federal Highway and NOAA, and we are looking at specifically the effect of the sea level rise. We want to see that, okay, based on the climate change, how much sea level rise we are going to have, and how is that's going to impact our surface transportation, basically performance. And as part of this project, we are going to quantify the vulnerability of the surface transportation systems to sea level rise and inundation, how we can quantify social, economical, and ecological benefits of some of the prevention methods, and how we can predict the impact of the sea level rise and the performance of our infrastructures. The two projects that already started under this collaboration is one of them is with Auburn University. The title is Surface Transportation, Sea Level Rise, and Coastal Storm, a sustainable path to increase resilience. The second one is with the University of New Hampshire, that's Coastal Communities Pavement Resilience to Sea Level Rise using natural and nature-based features. One of the very newer project that we are going to look is impact of wildfires on pavements. As everyone knows that now wildfire is becoming more issue for our pavements and infrastructure. So this project is going to look at the state of knowledge and trying to identify the research gap and needs. So basically, this is a preliminary stage, to identify what are those direct and indirect impacts of wildfire on our pavements, and then what are the basically questions that we can answer and address for our stakeholders. One of the things that is important in our process is a resilient roadmap. We are trying to have all these different pieces of the puzzle together and have a roadmap. And to get to it, we have done some peer exchanges, both on resilience for the pavement, for the wildfire. And one of the things that was important for us, we noticed that education is very important on the resilience topic for our engineers. So we are putting together a National Highway Institute Resilience course, or NHI course. Also, we are putting together a pavement resilience technical guideline. This guideline has been completed. We are now going through the publication process, and hopefully we can have that one published in early 2022. And how can you help encourage your agencies to consider resilience in the planning, design, and operations, and help disseminate some of these resilience resources that we have, these case study, these tools that they are all for free. And as very important, to continue research on that. These are some of the references that I use for my presentation. And with that, I thank you for your time, and I would welcome any question that you have.